Hi, I'm Barry Nance of Network Testing Labs, and I review computer hardware and software. Since 1989, I've put thousands of products through grueling tests to find out which ones work and which ones don't. I recently ran across rather alarming behavior while testing H.I.P.S. products. The behavior, plus some research, led me to conclude that firewall architecture H.I.P.S. products are deeply flawed. If you're contemplating getting an H.I.P.S. to protect your network, avoid, like the plague, products that use firewall technology to detect intrusions. They simply do not work. I think you'll reach the same conclusion in a moment because I'm going to show you exactly how hackers easily bypass a firewall-based H.I.P.S. Symantec's and Kaspersky's H.I.P.S. products are, unfortunately, examples of firewall-based technologies. In contrast, products from McAfee and Cisco use a higher quality, much more successful approach that intercepts system calls and kernel API calls. Let me show you the difference between the two approaches. In a series of tests, I put Symantec Endpoint Protection up against McAfee Total Protection for Endpoint. I downloaded an evaluation copy of each product from each vendor's website. My test environment consisted of 3 systems: one attacker system, one system running the Symantec product, and one system running the McAfee product. Note that the attacker system might be external, or it might be a hijacked, unsuspected local machine on your network, a bot. On the attacker system, I ran a tool called Metasploit to hack into each of the other 2 systems. Metasploit is a highly useful open-source vulnerability testing tool. For ethical hacking purposes, you may want to get Metasploit to use on your own network. For this test, I specifically wanted to see how each H.I.P.S. product reacted to a Configure variant exploit that uses buffer overflow to gain access to or run malware on a victim client or server. The MS-08067 exploit within Metasploit fit the bill perfectly. Let's challenge the Symantec protected system first. In this first test, I'll use Metasploit to attack the Symantec H.I.P.S. with a Configure variant. You're looking at the Symantec protected system. As you can see, the Symantec client has all the defenses turned on and everything is up to date. Let's turn next to the Metasploit system screen. Launching the attack is fairly straightforward with Metasploit. I simply choose the exploit, the Configure variant, specify which payload to use, just a remote shell in our case, enter the target IP address, and then initiate the attack. For our tests, the payload I specified is just a remote shell that will let us execute programs on the target system. Of course, I could have chosen something far more damaging. Look back at the Symantec protected system. You can see the expected results appear. The Symantec software displays a pop-up indicating MSRPC Server Service BO detected. Now let's attack the McAfee protected system, and let's use exactly the same exploit. You're looking at the McAfee protected system. As you can see, McAfee is also turned on and updated. Look now at the Metasploit system, and watch as I use exactly the same steps as before to launch the Metasploit attack against McAfee. On the same Metasploit screen we used earlier, let's change the IP address to target the McAfee system and launch the attack. As expected, McAfee detects the intrusion and displays the alert message, "Vulnerability in server service could allow remote code execution." So far, so good. In our initial plain vanilla simple test, both systems detected the intrusion attempt. But what happens if we tell Metasploit to use some fairly well-known and all too common IPS evasion techniques? Let's tell Metasploit to use packet fragmentation and see what happens. Packet fragmentation is a common IPS evasion technique that can be the Achilles heel of firewall-based H.I.P.S. products, rendering them completely useless against intrusions. And how will the kernel-level McAfee H.I.P.S. behave when we attack its computer with the same packet-fragmented exploit? Let's see how the Symantec and McAfee products react. Look back again at the Metasploit system. Let's first change the IP address to target the Symantec protected system. Then let's scroll down and expand the Evasion section. We'll change the max packet fragment size to 40 bytes and launch the attack. Now let's inspect the Symantec protected system. Uh-oh. A remote shell payload got through Symantec software and is now running on the target system. From the Metasploit system, we can now run programs on and control the computer that Symantec is supposed to protect. We've rather easily hacked the target computer, which could have been one of your critical servers. Now let's attack the McAfee protected system with the same exploit, and we'll use the same H.I.P.S evasion technique. Remember, this is not some esoteric, rarely used approach. Hackers use these evasion techniques all the time. Look at the Metasploit system. We'll change the IP address to target the McAfee protected computer, and we'll make sure we're fragmenting the packets into 40-byte chunks. We'll launch the attack. Looking at the McAfee protected system, we give a sigh of relief. McAfee's H.I.P.S has successfully detected the packet fragmented buffer overflow exploit. We see the alert message, "Vulnerability in server service could allow remote code execution." Our hacking attempt failed. We do not have remote shell access to the McAfee protected system. I suggest you avoid using a firewall-based H.I.P.S, such as Symantec's. It can exhibit many bad traits, one of which you've seen here. Instead, when you evaluate H.I.P.S products, look for a layered approach that includes kernel-level protection. While signature-based firewalls can stop some attacks, they can fall down on the job when confronted with some rather common IPS evasion techniques. In our testing, the McAfee H.I.P.S put up the highest, strongest barriers against hacking attempts. We recommend you look closely at McAfee's H.I.P.S in order to best protect your computers.